Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios. And today what I have for you is a reaction to the latest software development, architecture and design 2023 trends, so architecture trends for 2023 from InfoQ. Before we go into the article, just some news. I've done yet another one of our learning programs on secure coding, and it has proven to be extremely successful. I had a lot of fun with developers and testers, figuring out what the mindset of attackers is and how to get into this mindset, and then how to defend against these types of threats. I had a lot of fun, they had a lot of fun, so I wanted to share this piece of news. It's really cool to do this learning program again and again and have such a interest from participants. With this being said, let's move to our main order of business, which is the InfoQ architecture report. This is the trends report published in April 2023. It's published by Thomas Betts, laureate application architect at Blackboard, and Blanca Garcia Gil, senior analytics engineer at Topai. I have reacted to this InfoQ trends report in the past. I think the last one of them we definitely reacted, and they are very interesting. I find them very insightful, which is why I think it's quite interesting to see what they have to say. So this was published very recently, April 7, 2023, and as usual it starts with some key takeaways. But I like to look first at the picture that they added here. This is the trends picture, and they split it based on the adoption curve. So we start from late majority, we'll start from innovators, early adopters, early majority, and late majority, and this is where we have a chasm, because people who are early adopters, they don't really like what's happening in this side. So usually it takes a bit of time to get to early majority, because it upsets a bit the early adopters, but on the other hand it's difficult to get to the early majority. That's the fundamental idea with this adoption curve. But let's start talking from the late majority side, because I find this more interesting. What they are seeing is that there are a few architectural practices that have been adopted by a lot of organizations, apparently. Serverless reactive programming, HTTP2 and gRPC, event-driven architecture, CQRS, event sourcing, eventual consistency, microservices, and domain-driven design. Now, I find this to be very interesting, because while I believe this is true based on what I see in organizations, there are also some interesting things to note. On one hand, microservices, the implementations are still with a lot of issues. I think that still a lot of organizations struggle with the fact that when you switch to distributed architectural model, you will have a lot of challenges. It's very different from having monoliths or even large services. Switching to microservices creates problems like eventual consistency. But they actually see that eventual consistency is in the late majority. And that's interesting. Many of the, of course, I may be biased because when organizations ask for our help, they have troubles with these things. So maybe I see a selection bias. That's definitely possible. But I find it quite difficult to believe that most organizations actually realize that this is that microservices and eventual consistency need to come together and come to terms with that. The other thing here is event sourcing. Event sourcing is a very specific architectural pattern in which we write events to a, so instead of writing the current state and updating the state of the program, what we are doing is sending events and storing events. So it's very interesting to see this happening. Now, event sourcing opens a lot of possibilities. And if you want to learn more, take a look at the interview I did with Matthias Ferrais. He's talking at some point about the possibilities that are created by event sourcing. So it would be, it's a very interesting approach, but it's also very different from what we are used, and it also creates a bit of problems, particularly with things like GDPR and other privacy issues in it. Yeah, it's basically a different architectural paradigm than what we are used to, and because of this, it creates a bunch of challenges. So I'm curious how they think that this is actually happening, that we have event sourcing in the lane majority. The other thing, domain-driven design. Domain-driven design is a very big area, and there's a lot of issues here. So you can make domain-driven design really well, or you can use it poorly. So seeing domain-driven design here in the lane majority makes me wonder how many organizations actually are using it properly. That's a big question. But probably it's in combination with microservices. You need domain-driven design if you want to do microservices correctly with eventual consistency. The other ones are not as surprising. I mean, serverless, no-brainer if you want to reduce operational costs, particularly for cloud-based operations that have a very how to say, the calls are not constant throughout the day, but they vary a lot. You have occasional calls. This makes a lot of sense. And also for various things like batch operations sometimes, or other stuff like that. Reactive programming definitely makes a lot of sense for real-time data series, and there's a lot of analytics and data that we are looking at in big organizations. So definitely not a surprise. HTTP2 and gRPC, these are again kind of no-brainers. HTTP2 increases the speed and security of and reduces the latency of calls, particularly if you have services based on HTTP. Using HTTP2 is just, it makes sense. gRPC also helps with optimizing particularly internal APIs. So again, makes a lot of sense. Event-driven architecture is something that, particularly in combination with serverless, with microservices, again, makes a lot of sense. So I'm not as surprised by this. I have my doubts regarding to the level of implementation of the others. Now let's see the early majority. Architecture decision records, modular monolith, correctly built distributed systems, actor model, GraphQL, service mesh, and functional programming. So this is what they are seeing as being in early majority, and I find it very interesting. First of all, that ADRs, architecture decision records, have crossed the chasm. If that's true, this is brilliant news, because as I said in a number of occasions, this is very, very useful. It's a very useful technique worth applying. Modular monoliths, well, I am still unsure that we know in this industry how to architect modular applications in general. So I have my doubts that what is called here a modular monolith is actually what I would call something that's modular. A modular monolith would be formed of different parts that are cleanly separated, and basically you could extract one module as a service if you want to, or you could replace one module with another module. So this is quite interesting to see. Maybe it's true, but I'd have to see more products to be sure. I'd really love to see that we are actually building modular applications. But I think one key here, something that is still not that possible in modern programming languages, is having modules with strong boundaries. Only recently we started having in Java and in C++ actual modules that have strong boundaries. Otherwise, you are bound by rules and by following certain guidelines. And as we know, programmers often, when they only have guidelines, they often don't follow them. So I'd be curious to see some examples here. Correctly built distributed systems. Well, I find this weird that it's just in the early majority when we have microservices and eventual consistency here, because basically this combination is key for correctly built distributed systems. So, yeah. I also find it interesting that we have the actor model here. The actor model is a pretty old model. If I remember correctly, is for distributed or asynchronous jobs. And it's one that simplifies a lot these types of applications. It's really worth using. Apparently, it took a while to get to the early majority, because if I remember correctly, I knew about it like in the 90s or 2000s. I'll have to check, but it's definitely a very old model. And seeing that only now it gets to the early majority doesn't surprise me, but I am surprised that it got to the early majority. I would expect it to still be unknown. But maybe there are some libraries that have promoted that, and because of the adoption of those libraries, we actually got to adopt the actor model. Service mesh, again, a no-brainer, makes a lot of sense, particularly for security and configuration and so on. So absolutely. GraphQL, I'm not such a big fan, but I understand why you need something like GraphQL, particularly in organizations where you have a bunch of APIs and you need to take data from one place to another and do a lot of plumbing like that. it makes sense to have GraphQL interfaces in that situation, because you are able then to carry data very easily over APIs. I'm not a big fan because it tends to be coupled with the data structure, and that is not such a good idea. But it answers one problem with REST, because in REST APIs you don't have a clear model for queries, and because of that, GraphQL can compensate this issue. But I would really love to see other solutions here. Now, getting to the early majority, it means that it's easy to use, basically, because you have tools, you have ways to generate this, you have a query language. So it makes sense. It solves the real problem. Even though I'm not a big fan, definitely understand the pragmatic uses of it. What I'm really surprised by is functional programming. Seeing functional programming here, functional programming has been around since the 40s or 50s. Functional programming has been around since before object-oriented programming. So this is, to me, extremely surprising to see that we got it here in early majority in 2023. I imagine that this is because of the newer programming languages that use functional programming. Maybe JavaScript is assimilated here because you do kind of a functional programming there. But I'm not sure that it's actually that it actually means what I would say by functional programming. I would have to see this. It would be quite interesting. All right, so yeah, cool. Now, early adopters. So these are technologies or practices used by fewer people or fewer organizations, but that have potential. So they are in the early adopting phase. Design for portability, and I think they talk about this a little bit. It's more about portability between different cloud services, and we have now certain frameworks that allow us to do this, so it will be interesting. We'll go into more details later. Data-driven architecture. I don't understand why this is in the early adopter phase, because most microservices, so domain-driven design is actually a technique for data-driven architecture. It can also be a technique for event-driven, but initially, if you're doing so you can do two things with domain-driven design. You can do domain models and start from the domain models, design the bounded contexts, design microservices around the bounded contexts or other types of components, or go with event storming, which leads you to a kind of event-driven architecture. But in the end, that is still more or less data-centric or data-driven. The only thing here that is not really data-driven is gRPC. Everything else, well, event-driven, you might say, okay, it's about time-based events. It's not really about data. Okay. It's very close to data, but not the same. gRPC is the only one that focuses on the other style of architecture, which is behavior-centric. So seeing here data-driven architecture in early adopters, while in the late majority we have a lot of stuff that relates to data-driven, I find it a bit weird, but maybe it means something specific for them. Architecture as a team sport. that's interesting. We'll see more details. I think they talk more about this in the article. WebAssembly, server-side and client-side. Now I'm very excited about this thing because I honestly believe that we should get rid of JavaScript sooner or later. And there are two ways of dealing with that. One of them is enhancing HTML, and this is what the HTMX library has done. And maybe you know I have a whole series of learning HTMX and programming with this library, and I really love using it. And the other solution, the other side of this, is WebAssembly, which basically takes the building blocks of client-side code, but you can then take those building blocks and compile them to JavaScript, or you can compile them to something else, or write the code in something else. So fundamentally, if your browser is your operating system and JavaScript is your programming language, what we were missing until 5 years ago was the assembly language, the low-level language that allows us to run and to use multiple programming languages that compile into the same assembly. And now we have that. We have it actually for a few years, but apparently now it has become possible to have server-side and client-side WebAssembly. It was possible, but it was quite difficult. I want to do an example with WebAssembly sooner or later, but I kept looking at the state of tools and languages and so on, and it was still quite complicated. Now I'm really curious, since it passed into early adopters. Intuitively, I would think that here we would have some additional support from tools or programming languages and so on. I really love to see this working. So I love the idea of WebAssembly, and it makes a lot of sense, particularly for things that are possible, that are more difficult in JavaScript, and easier to do in other programming languages. Then design for security, design for resilience, design for observability. I'm very curious why these are in early adopter phase. I've always talked about security resilience when we do architecture courses and when we work with clients. So to me, these have always been key elements in architecture. So I don't understand why only now they are in the early adopter phase. Observability is more difficult, or a newer thing, more or less. It makes sense, particularly with the complexity of systems increasing in time. Observability becomes a must. So this makes a lot of sense. I'm not surprised that it is in the early adopter phase, because I think we still don't have the patterns, the tools here. But it is something that, particularly for larger organizations and more complex systems, you need to take into account. Then micro frontends. I'm surprised to see them only in the early adopter stage, but well, async API, workflow and decision automation platforms. All right. So these are kind of, and low code, no code. Now the problem here with low code, no code is that this is still code. Okay. We might believe that it's not code, but it really is code. So we need to be very careful here, and particularly one of the things with any low-code, no-code platform, including workflow and decision automation platforms, how can we test that it works? How do we know it scales? How do we know it is secure? And so on. So this creates a lot of questions. So yeah, I'm curious to see what they have to say about this. Now, innovators. So here there are a few things that I'm not so familiar with. dApps, I don't know what these are. I hope they are detailing it. HTTP3, even better, more improved than HTTP2, so I think it makes a lot of sense to adopt it, but it's definitely a longer term thing because you need to upgrade servers, web servers, you need to test, you need to adjust settings in your infrastructure. It's not something that's just, you deploy it and then it just works. You actually need to do some infrastructure work for it. Policy as code, I think this makes a lot of sense. GraphQL Federation, I'm not sure what this is about. So it's probably an extension for GraphQL. Have to look at it. Design for sustainability, I think this refers to, for example, the carbon footprint of your products. I've said since, I think, last year that this is something that will become a requirement for architectures sooner or later. Software supply chain security, yeah, this is again and again something that's very important. We have seen also the bill of materials, software bill of materials, tools and practice, and ensuring the supply chain security is very, very important, particularly given the increased attacks, increased cybersecurity attacks. And large language models, things like GPT. So we've done a full video on large language models and software development. I'm curious what they have to say, but I haven't changed my opinion much since I've seen some new developments in this area, but it looks to me that the model will be the same. You play around until you get good prompts, and then with the prompt you generate some code, and then you need to test and verify that code. And maybe we'll figure out a way to give to large language models smaller steps, take step by step and automate little by little through these prompts. But honestly, I'm still not certain that this is something that will make a lot of sense. We'll see. Probably maybe at some point it will become better, but right now it looks to me like you need to work. So if you know what you're doing, it slows you down, and if you don't know what you're doing, it's very difficult to find the errors in the model. So I'm not sure. Maybe it's better than this, but we'll have to see. All right. So they also have a podcast about this. Let's look at a few things that they are talking about. Design for portability. The portability aspect of design for portability is not about being able to pick up your code and move it. Rather, it creates a clean abstraction from the infrastructure. As InfoQ Victor Vasco Veloso says, whoever is designing and building the system can focus on what brings value instead of having to worry too much with the platform details that they are going to be running on. This design philosophy is being enabled by frameworks such as dApps. A recent article by Bilgini Briam described the evolution of cloud-native applications into cloud-bound applications. Instead of designing a system with logical components for application logic and compute infrastructure, cloud-bound applications focus on the integration bindings. These bindings include external APIs as well as operational needs such as workflow orchestration and observability telemetry. So this is interesting. I think dApps is an interesting idea. This is the official dApps website, and it talks about general patterns like invoke, store, publish, subscribe. I kind of like the idea because it abstracts away the infrastructure. Now, I have not used this. I would be very interested in actually trying it because I think it makes a lot of sense. One challenge, though, with anything that increases abstraction, so having a clearly defined abstraction layer and API, the issue here is that whenever you increase abstraction, what you get is a metaphor, and then the metaphors, there's a phenomenon called metaphor shear, which basically means that at some point the metaphor doesn't work anymore. Your abstraction breaks. So generally, these types of abstractions are good ideas in principle, but in practice you often find out that you have written your application in a certain way, deployed it on AWS, and then when and if you want to move it to another cloud provider, you realize that it's not actually the same and you need to adjust some things. So the portability aspect tends not to be such portable. If you have experience with dApps, let me know. What are your experiences? Let us know in the comment. It would be good to learn. But generally, yeah, it's interesting. And then another technology that supports designing for portability is WebAssembly, specifically server-side WebAssembly. Often WebAssembly is thought of as a client-side capability for optimizing code running in the browser, but using WebAssembly has significant benefits for server-side code. So instead of compiling it to a Docker container and then needing to spin up an entire system inside that container on your orchestrator, you compile it to WebAssembly, and that allows the container to be much more lightweight. It has security baked in because it's meant to run the browser, and it can run anywhere, in any cloud or on any CPU for that matter. That's actually very interesting. I haven't thought about that, but indeed, because WebAssembly is built to run on a browser, it is sandboxed by default, which makes it more secure, at least in principle. That is very interesting. I'd be curious to read more about this. All right, we got into large language models. So the question they are trying to answer, what does it mean to software architects? Things like GPT-3 and GPT-4. In some ways, it is too early to know what will happen. I absolutely agree. With ChatGPT and Bing, we're just beginning to see what is possible with large language models like GPT-3. This is the definition of an innovator trend. I don't know what will come of it, but it will be significant and something I look forward to seeing evolve in the next few years. This is Thomas Betts, a quote from him. So the basic thing is we don't know, because these AIs have limitations. So it's fundamentally what we have discussed in the previous video. Data-driven architecture. Last year we discussed the idea of data plus architecture as a way to capture how architects are considering data differently when designing systems. This year we are combining that idea with data mesh under the heading of data-driven architecture. Alright, so forget what I said about data-driven architecture in the introduction. It's actually something quite different. It's a bit confusing that they are using this term, but yeah, there's a lot of clashing terms in architecture. The structure, storage, and processing of data are upfront concerns rather than details to be handled during implementation. Yeah, but this is actually the definition of... This is what I think about when I think about data-driven architecture and about things like domain models and domain-driven design. So I was right in the introduction. Blanca Garcia-Gil, a member of the QCon London programming committee, said when designing cloud architectures, there is a need to think from the start about data collection, storage, and security, so that later on we can derive value from it, including the use of AI/ML. That's true. So maybe there's an additional need or additional concerns related to data, particularly the fact that we need to use AI and MLs. But honestly, the way this has been done until now is probably the same way that people will do next, which is ensure that they are also storing data into a data lake or something like that, and then prepare it for analysis. Because AI/ML is basically, it will use the same patterns that we use for analysis. I don't think it's a big difference. But, actually, data mesh was a paradigm shift with teams aligned around the ownership of data products. This fits the idea of data-driven architecture, as well as incorporating Conway's law into the overall design of a system. Now, this is interesting. This is indeed interesting. On the other hand, this is precisely what should have happened with microservices. So, yeah, not sure it's such a paradigm shift, or let's say probably it is a paradigm shift, but it's not something as new or such a big innovation. It's something that should have happened anyway. All right, design for sustainability. Yeah, so here designing for a low carbon footprint, absolutely. I think there is more talk about sustainability these days. Probably half of it is because energy is more expensive. Yeah, absolutely. So the energy price has increased, but then we are also going in a direction of reducing carbon footprints, and it's difficult to do that, as they are saying here. Very interesting. So there's a foundation. The Green Software Foundation is one initiative trying to help create tools to measure the carbon consumed. Interesting. This will be quite difficult to do. And it would be interesting to see the results. Like, what is more carbon intensive? C++ or Python? Well, it's already very difficult because, okay, maybe compiled C++ will have less than interpreted Python, but then if you compile Python programs as well, maybe they will be the same. And also the compilation costs for C++ tend to be higher. So yeah, it will be interesting to see. Will we have to write C++ code to reduce carbon footprint? That will be an interesting thing, or Rust for that matter. As the tooling improves, developers will be able to add the carbon usage to other observability metrics of a system, and then the system can be designed and modified to reduce them. Absolutely, yeah. So, yeah. Oh, dApps, decentralized apps. Okay, now I get it. Blockchain and the distributed ledger is the technology behind decentralized apps, mostly due to changes at Twitter. Mastodon emerged as an alternative decentralized social network. However, blockchain remains a technology that solves a problem most people do not see as a problem. Because of this niche applicability, it remains classified as an innovator trend. So I find this a bit misleading because Mastodon does not use blockchain. Mastodon uses ActivityPub, which is a specific protocol, and it's just basically building upon the structure of the internet. This is what Mastodon is doing. And because of this, it is a bit difficult to understand by users, because users, if you're using Twitter, there's one instance, you only go there, it works in a one way for everybody. If you try to use Mastodon, you start getting into a bunch of issues, like there are a bunch of instances. Each instance has different rules and different focuses, and you have a local feed and you have a combined feed, like coming from all instances. And one instance of Mastodon can block other instances of Mastodon, or can block specific things, or from other instances, or can block, groups of instances, and so on. So it's much more difficult to understand, but it's much more natural for the internet. It's something that makes sense for internet. And I really love that we are starting to see decentralized social networks. It was their time. I think they should have been here since, 5 or 10 years ago. But Twitter was such an easy application to use. And with the recent developments, it's, for various reasons, people have left Twitter and looked for something else. And yeah, this is how Mastodon emerged. And honestly, I love the Mastodon instance I'm on. I love the product. I get much more interesting conversations there than on Twitter. So yeah, but it's a socio-technical thing. So it's not only the technology, not only the product itself, but it's the community that was attracted there and the way it works. It's so good to see toots, Mastodon, they are called toots compared with tweets, from the people you follow in the order they were posted, instead of all kinds of algorithms and stuff like that that were just optimizing for noise from my perspective, right? So I haven't left Twitter. I'm still there, but I love Mastodon more now. So yeah, these blockchain still not adopted that much, and I understand Mastodon is probably, even with a big spike in adoption, is probably not yet a large scale adoption. So absolutely, but it's a nice place to be, at least from my perspective. I know some people don't agree and they have some issues with certain policies in Mastodon. For example, quote toot, which is not available in Mastodon, and many people feel that it should be. All right, and for various reasons, which are absolutely valid. I won't comment on those. But for me, it's been a really good place. So yeah, join me there, maybe. Architecture is a team sport. Architects no longer work alone, and architects can no longer think only about technical issues. When could they think only about technical issues? I think about half the job of an architect is to explain things to other people. So, all right. The role of an architect varies greatly across the industry, and some companies have eliminated the title entirely, favoring principal engineers as the role primarily responsible for architectural decisions, just to make things even more complicated and more confusing. This corresponds to a more collaborative approach where architects work closely with the engineers who are building a system to continually refine the system design, which is precisely what architects should have been doing in the first place, but all right. Architecture decision records are now commonly recognized as a way to document and communicate design decisions. I think we did a full video on ADRs, so check it out. All right. And in general, ADRs are really great. Oh, so there are actually more authors. Let me read all of them. Thomas Batts, lead editor for architecture and design at InfoQ, Laureate software architect at Blackboard, Blanca Garcia Hill, lead analytics engineer at fintech startup Topi, Daniel Bryant, head of DevRel at Ambassador Labs, Aaron Stiller, principal software architect from Melbourne, Australia, Vasco Veloso, okay, 20 years experience, and Tanmay Deshpande, technology and business architecture. I think in general I like this. I find this very interesting. I agree with the general trends. I think they captured most of the ideas really well. So yeah, take a look at this, and you can also check out the other side, which is the Tech Radar from ThoughtWorks, and I think we also did a video about that, reacting to it. So you can look at the two and combine them, because you'll find some of these things on both, and it's very interesting to see what's happening here. So in general, I think these trends make sense. Architects need to work in a team. They need to be to do more coaching and more hands-on work with teams. And if this is correct, that we are finally seeing microservices with eventual consistency and with correctly built distributed systems and so on, these are great news for the industry. from here, from the left side, low code, no code is here to stay. I'm pretty sure that there is a place for low code and no code, but I think there will be a selection of platforms. Some of them will survive, and the best, hopefully the best ones, will survive. And in terms of the innovators, the biggest unknown is large language models. And then the biggest question is actually software supply chain security and design for sustainability. These are big questions. We don't have all the mechanisms here, and there is some work done, but it's still not at the level where you can take it and say, okay, well, we can use this in production really easily. You need to still do a lot of work to make this happen. So yeah, this was my reaction to the InfoQ Architecture Trends Report from April 2023. I think it's very interesting, as I said. What do you think? Let us know in the comments. We love comments. We love answering comments. And if you have any experience with some of the things we talked about, with dApps, with some of these practices, let us know. With WebAssembly, how have you ever used WebAssembly on the server side? Have you tried using this? Would you be interested in trying it out? Let us know, and let's have a good conversation in the comments. It's always good to share with others and learn from each other in this community that is slowly growing. And I'm glad to see that it is growing. I don't want it to grow very quickly. I just want it to be a community of people who are very interested in key topics in software development, and I'm glad to see that more and more people join constantly. And it's time for you to also have some interesting conversations, right? So let us know in the comments if you have any questions, any comments, if you have any additional information regarding the things we talked about, if you tried any of these technologies, let us know how it worked. Thank you kindly for the view, and until next time, remember to think, design, and work smart.